Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very easy level puzzle, and it's called Aggregation Through the Fog by Megan33. So another Megan33 fog puzzle, which are always a pleasure to play through. Anyways, here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, every column, and every box. There is one and only one blue sum line. So this is the same sum line as this one, where box borders divide the line into segments of equal sum. So for example, this one must sum to the same number as this one because the box border divides it. And there is only one blue region sum line. So it could be something like that or along those lines where it connects. So every region that's divided by the box borders must sum to the same number. Digits along a magenta red band form a set of consecutive non-repeating digits in any order. So, for example, if this was a 1, you know there would have to be a 2 or a 3 on the same line because it would have to have 3 consecutive numbers, and 1 is only consecutive with 2, which is only consecutive with another number of 3. So it would have to be 1, 2, and 3. So, and remember, they're non-repeating. So if the red band ever goes across lines, across borders essentially, and then you could have potentially multiple of the same digit on the red band line, you cannot actually do that because they don't repeat. Okay, a black dot between cells indicates cell values with a 2-to-1 ratio. So for example, if this was a 2, this would have to be a 1 or 4 to maintain a 1-to-2 ratio. A white dot between cells indicates cells with the consecutive values. Not all dots are given. So if this was 6, this would have to be a 5 or a 7. And basically, not all dots are given means that there are no negative constraints. So that means we have just positive information about the cells where the dots are in between. There could be other cells which are consecutive, which are next to each other, which do not have a dot, or which have a 1-to-2 ratio, which do not have a black dot between them. It's just saying that we know there's specific information about these cells. Adjacent to cells connected with an X must sum to 10. So these two must sum to 10. Adjacent cells connected with a V must sum to 5. So wherever say this was a V, these two would, okay, say this was a V here, then these two cells would have to add up to 5. The grid is partially covered with fog. Correctly placed digits will clear the fog around that cell. No guessing is required. So basically, you should be able to logic through all of this, and don't guess, because it does take kind of the fun out of these puzzles if you just guess randomly. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so these add up to 10. So this is 1, 2, 3, 4, 6, 7, 8, 9. This is in a 1-to-2 ratio. So this is 1, 2, 3, 4, 6, and 8. If this is 1, this would be 2, but then this rim band doesn't work anymore. So this cannot be 1. If this is 1, this is 2. If this is 1 and this is 2, this has to be consecutive with it. So this doesn't work because this would be 1, 2, 3, and then this 2 doesn't have anything to be consecutive with. So this can't be 1. If this is 2 and 4, if this is 2 and this is 4, it has to be consecutive with one of these, and then the other 2 unfortunately doesn't work, right? Because if this is 2, this would be 4, so you can't have 3, 4 here, but then one or 3 has to be here, so you can't have 1, 3 here, therefore this doesn't work. So 2 cannot be there. 2 could be here, though. If this is 2 and this is 4, this could be 3, 5, 6, and that works. I think 3 and 6 also work similarly well. So this must contain a 4, or it must contain a 6, right? It's either 4 and 2 or 4 and 8, or it's 3 and 6. So this can never be 4 and 6, right? If it's 3 and 6. Okay, so what happens if this is a 3? If this is a 3, this has to be 6, which means this has to be 4. And this would have to be 1 and 2, because it cannot be 4, 5. Actually, it could be 4, 5. Hold up. If this is a 3, this is a 6. You know, it could be 4, 5. So that works, actually. If this is a 3, this becomes 4, 5. This has to be 2 and 8. So let's do all the possible. Oops. I pressed check accidentally. This is 3, this is 6, this is 4, 5, this is 2 and 8. That works. If this is 4, say it's with 2. This is 3, 7. This is 4. This is 5, 6. So that works. If this is 4 and 8, we still could be 3, 7, 5, 6. That works. Or it could be... It can't be 5. So it'd have to be 4, 3, 5, 6. Yeah. So it cannot be 5 here, because 5 can never be with another digit in form of 10 in normal Sudoku. So 4 and 8 could be here. So that works. 6 and 3 is interesting. So 6 could go 5, 4, which is fine, and 7, 3. 6 cannot be 5, though. So far 5 has been here all the time. Oh, that's true. So these two sums add up to add up to the same number. So that means it's 2 times something, which means this must be odd. So that means there's 2 odds and 1 even. So it cannot be 4 or 6. So far. 6 cannot go down to 5. Oh, hold on. Right. Okay. Yeah, that's the logic here. These two numbers add up to the same sum, so they're essentially 2 times a certain value, let's say x. The whole box itself adds up to 45. So for 45, if you subtract out an even number, it must be an odd number. So these must sum to an odd number. Now the thing is, with this being consecutive, this digit here has to be the endpoint of one of the Renbands. So if it's even, it goes even, odd, even. If it's odd, it goes odd, even, odd, which is the only one that... Wait, no. It has to be even. So it has to be even, odd, even. So there's one odd, which means this is an odd... how do you say it? An odd value. Yes. So therefore, this must be even. So 3 does not work, so this cannot be 6. 6 and 3 work, so this is 5, 4. This would be 7. It cannot be 6 and 5. The 4 can go down to a 3 or 7. Oh, wait, 6 cannot work. If it's 6, it's 7 and 3, right? If this is 6, this is 7 and 3, but then the 6 has to be with a 3. So this 6 does not work. Therefore, we have 4, 5, and 6, which makes 3 and 7 so far. That works. And this can go with either 2 or 8. But this doesn't work. These two add up to each other. If it's 4, 5, 6, that's 15. So these two must add up to 30. Divided by 2, it has to be 15. But then this requires this to be 3, 7, and 5. So none of those so far work, which means this has to be probably 8. 8 and 4. So it has to be down. So this has to be 9. This is 1. This is 7. Not 9. This is 6 and 7. So this adds up to 21. Yes, 21. 45 minus 21 is 24, so this adds up to 12. So this is 1, 2, 9, and this is 3, 4, 5. And we know this has to be the solution because none of the other solutions work. So this is 8, 9, 1, 2, 4. So now each segment of this region sum line must add up to 12. There's 2 digits in this one, so this has to be 3, 9. So it could be 9 and 3, 4, 8, or 5 and 7. This can't be 5 because this it's next to a 10. So this is 3, 4, 5. This is 1, 2, or 3. This can't be 3, so this can't be 7, so this can't be 5. This is a 1 to 2 ratio, so this is 6 or 8. If this was 4, this would have to be 8. It could be 2. Okay. Well, if this is 4, this has to be 8. But that would be 2. But then that would eliminate all possibilities for the black Kropke dot. Therefore, this is a 3. This is a 9. This is a 1. This has to be 6 then, which is 4. So that adds up to 10. This can't be 3, so this has to be 5 because it's consecutive. This cannot be 1, 4, so this is 2, 3. Therefore, this must be 7 or 8. Because there's only the only two sets of digits can add up to 5 is 1, 4, and 2, 3 that are 2 digits. This cannot be contain 1, 3, or 5, so no 1, 2, no 2, 3, no 3, 4, no 4, 5, no 5, 6. So it's either 6, 7 or 7, 8, and it cannot contain a 9. So it's 6, 7 or 7, 8. Or 7, 8. So the 7 has to be there. This cannot be 3, so it can't be 3, 6. It cannot be 8, so it can't be, or 1, so it cannot be 1, 2, or 2, 8. So this is 2, 4. Oops. This is 2, 4, which means this has to be 6 and 7. This is 6, 7, or 8. We have 1 of 2 or 4, or 1 of 6 or 8. So this can't be 2, 4. So this is 6, 8. This can't be 6, 8 because we have a 6, 7, 8 triplet in box 4, and that eliminates 6, 8 from the rest. We have a 6, 7, 8 triplet in column 2, so the rest of this is known. So this cannot be 6, 7, 8, 2, 4, and 9, so this is 1, 3, or 5. This must add up to 12. And since we have a 4, the only other digits that can add up with it is 1, 2, and 5. So this is 1, 2, and 5. This can't be 5. Therefore, this is 5. These are consecutive, and it cannot contain a 1, 2, 4, 5, 6, 3, or 9. So I think it's 7 or 8, right? No 1, 2, 3, 4, 5, no 6, no 9. So this is 7, 8, yeah. And therefore, this is 3 and 9. This is a 2 or 3. It has to be more than 3. 5. So this has to be now 2, 4, and 5. This is 3, and this is 3. Therefore, the 3 has to be over here. This can't be 2. One of these becomes 9. This can't be 2, 3, 4, or 6. So it could be 1, 5, and then 7, 8, 9. And we know the 9 is here. Okay. This is 7. This is 7. This cannot contain 2, 4, 5, so this is 1, 3, 6, 7, 8, 9. The 7 cannot be here. This is 12. This is already 12. This has to be 12. Huh. So that means this number must go through this way and then come back at least. So it could be like 417 or 236. It also that works both ways. Huh. 7, 8, 7, 8. This has to be 7. The 7 is over here. Oh, this can't be 4. This can't be 4, so this is a 2, which makes this 4, which makes this 2, which makes this 1, this is 5, and that's 2. This can't be 5. This has a 10 in between, so this has to be 1 and 9, so this can't be 1 or 9 here. These 4 digits must add up to 12. And the only 4 digits that could be is 2, 1, 3, and 6. So this is 6, this is 7. This is 1 and 3, so this is 5. This has to be 4, 8, and 9. So this cannot be 8 here. So 8 is one of these two. We don't know which. We can remove the 7 in the check mark, or in the corner. 1, 9, 1, 9. This cannot be 1, so it can't be 1, 2. Can't be 3, so it can't be 3, 6. So it's 4 with 2 or 8, and 2 cannot be here, but we don't know about this. So 4 is here. This can't be 4. This can't be 4, so 4 has to be one of those two. Okay. What are we looking at here? So 1 cannot be here. So 1 is one of these 3. This is 1 or 9. If this is 9, the problem is it's consecutive, so it continues here. So if this was 9, this would not work because it has to go through 2 other cells, and it has to add up to 12, and therefore this would have to be 1 or 2, and then we have another 1 or 2. But this can't be 1, first of all, so you can't have a 1 or 2. So this has to be the 1. This is 1, this is 9, this is 3, this is 1. Did that logic make sense? If we had a 9, it had to be in with 2 other digits because we know it connects eventually to this line. So therefore, it would have to have 1 and 2 specifically. But 1 is already taken care of in this box, and it can't go out of the box without having 2 other digits. So at minimum, it would be 9 plus 2 plus 3, which would be 14. And that doesn't fit the region sum. So that's the logic there. We know the 4 is here, so this cannot be 4. This has to then be a 3, 6 pair because 1 is already taken care of. So 4 is with 2 or 8, but then the other one doesn't fit. So this has to be 3 and 6. So it's 1, 5, and 6 that adds to 12. This is 2, 7, or 8. It can't be 2, so this is 7 or 8. Then therefore, this is 2, and this is 4. This cannot be 1, 2, or 4, so this is a 3, 6 pair, because that's the only one that fits. 8 can no longer be here. This can't be 4, so this is 9. Therefore, this is 5. 9 can no longer be here. We have 4 digits which add up to 12. So this is now 1, 2, 4, 5. So this has to be the 4. This is 1 and 2. This is 8. This is 4, which makes this 8. This has to be 1 and 2. This has to be 7 and 9. There's no 8 here. There's no 4 or 5. So this is 2. This can't be 8. So it could be, so these add up to 12, so these two add up to 10. It cannot be 6, and it could be 1, 9, or it's 3, 7. We don't know which. This can't be 2 anymore. This is consecutive with this, so it has to be 3 or 6. So this can't be 7. We have a 3 to 6 ratio. 3 to 6, we have 2 3 6s in column 8, so therefore that eliminates 3 6s. In the rest of the column. So this can't be 3 or 6. So this can't be 3. This is consecutive. So it cannot contain a 2. So no 1, 2, no 2, 3, no 3, 4, no 4, 5, no 5, 6. It could be 6, 7. And in fact, that's the only one that works. Right? Because 8, if it's 9, it has to be with 8. So this is 6 and 7, which means this has to be 9. So this has to be 1. That forces in in row 5, where's the 7? It can only be here. This has to be 3 then. This is 6, which forces this to be 5 to be consecutive. That's a 4. This is no longer 1 or 9, so this is 8. This has to be a 3 then. So this is 3, this is 9, this can't be 8, so this is an 8. This is now 6, 7. This is 6, 7. Okay, so this is 6, 7, and this has to be the 3. So this can't be 3. That's 3 in the corner. Let's celebrate. This can't be 3. This is a 6. This is a 3. This can't be 7. This is a 9. This is a 7. This is a 1-2 ratio. It cannot be 3, 6. It cannot be 1, 2 because that would eliminate both possibilities here. It has to be 2, 4. So this is 2 and... Whoops. This is 2 and 4. One of them's 2, obviously. So this can't be 2. This is a 1. This is a 2. This has to be a 9 now. So this is 9. And you have 3 digits that add to 12. So this, we know that's 2 and 1. So this is 2 and 1. This is 4. This can't be 2. So this is a 3. This is a 7 to go along with it. That's a 2. Which makes that 5 and that 3. This is 6. This is 7. This is just normal Sudoku. This is 8. This is 7. This is 8. This is 7. This can't be 4 anymore, so this is the 4. So we have, again, 4 digits which add up to 12, so it must be 1, 2, 4, 5, specifically because we can't have 3. So this is 1, this is 5. This can't be 9 anymore, so this is 6 or 7. It can't be a 7, so this is a 6, this is a 7, this is a 6. This has to be 9, 8, 5, and this is an 8. And that's a solution. Yeah, pretty straightforward, as long as you don't miss the 4, eliminating that 4 there. Yeah, it is what it is, you know. That is why I had the whatever checker on, because it saves me a little time doing busy work, but I mean, it is what it is. People suggested that I remove the conflict checker, so I did. And, you know, it is what it is. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.